All right, boys and girls, mostly girls, it turns out, but boys and girls who are allergic to cats, it's over, guys. Allergies are over. An amazing couple have invented, based on alpacas from the Andes, Evan, is that right? Evan Zhao and his wife Xiang Han developed a spray. They created it. It's called Pacagen. He's going to explain it, but you guys are inventors of the greatest kind. You're scientists, inventors, you have doctorates, you're such a cool couple. And now your wonderful cat can live with you and not make you have itchy eyes and sniffly nose and a tight throat. Talk about the evolution of Pacagen.
Of course. Thank you so much for having me. So, it started in 2020, so it was COVID. And I will say, first and foremost, my whole family, we're dog people. So we used to be dog people. And during COVID, everybody said if you were going outside, you were being socially irresponsible. So we wanted to look for a pet that could stay indoors. And my wife suggested potentially a cat. I looked online and I searched cats for sale near me. And there was only one in the area that was left. She was like this scrawny little baby kitten. And
Just to ask a question, Evan, were the shelters closed at that time? You
yeah,
could
it
go
was
to
a
shelters. You couldn't adopt during the early COVID. Everybody was truly locked down.
that's right. So that's why even all the nurseries for all the cats, they were sold out. Yeah. It was a very interesting time. But we saw Meow Meow, and her name was Luna back then, but we saw her and she was the last one, very skinny. And I put the down payment and we picked her up. And we had no idea my wife was allergic, Sion was allergic. We had no idea there was going to be any issues. And as soon as we picked her up, she just started sneezing, stuffy nose, everything you can imagine that comes with allergies. And we looked for a long time for something to help with it, and we've tried a lot of things. She was on antihistamines for a long time, so like Claritin or Benadryl. Benadryl made her really sleepy, so she was mostly on Claritin. And it worked a little bit, right? So those things just dampen your immune system, but it doesn't do anything about the actual allergens that are around. And the thing about allergens is the longer that you have the cat, the more there are because they're
Yes.
super stable. They stay around for years. There are
Is that
people.
true? Cat al Not just the cat stays around for years, but the droplets that go in the air and onto surfaces, those stay around for years.
Yeah, the actual thing that caused the allergies, those can stay around for 10 years or more. They are remarkably one of the most stable proteins to ever exist. And that's why sometimes somebody can go into a house that hasn't had a cat in it for 5 years and they'll still get allergies.
Interesting. So you guys, are you both scientists? Your doctor is from
Yeah.
Princeton. Were you on a science track, like to
Yeah.
work for a company? But of course, there were no companies at that time. The world was shut down.
Yeah. We were both in kind of drug development, therapeutic development. My wife actually, Seong, actually currently works for a big pharma company where
Oh,
they're
darn.
developing cancer drugs. And she does business development for them. And I like this space where we're using newer technologies for consumer issues that aren't directly therapeutic. I started a company called Ravella 4 years ago, which was it was biotech meets beauty and wellness. And we started a brand. We were selling serum with newly developed molecules in there to help with hair and everything hair related.
Oh, interesting. To
So
make it grow or to stop it from growing?
to make it grow.
Yeah. You mean like
So
Rogaine, but better?
yeah, so we did the entire drug discovery process. And that's how we view things, which is if you think about consumer goods, if you think about what's available for consumers that aren't drugs, that's stuck in the 80s. Everything that you've heard of for hair loss, everything you've heard of antihistamines, those are all from the 80s or before then. Rogaine is from the 70s or 80s.
Wow.
Yeah, and the other molecules are all way older. And
It's so great you're a scientist. Go, the other molecules are older. The rest of us don't think in terms of proteins and molecules, but
yeah,
that's your world. That's your canvas that you create from.
yeah. I mean, it's fascinating. There's over 3 billion molecules now. So there's 3 billion things that we can create that can potentially solve issues. And that's why cancer treatment has come a long way. It's why we've really been able to treat most types of cancer is scientists over the last 20 years with the advent of screening and all these other things that we do now, we can now create drugs for most types of diseases. And so all of the techniques that we've discovered over this last 20 years, what we do is we apply those technologies to other problems. So
Interesting.
Yeah, that's what we
So
did.
so this problem was an unsolved one. There's a pet food company that has a food that you have
Yeah,
to feed it to the cat, and it lowers potentially lowers the allergens, but you have to be
yeah,
willing to feed your cat that food, and your cat has to be willing to eat it. And there's some sprays that are
yeah,
out. Well, you spray the pet, but you had a different idea, which was to spray the
yeah,
environment. And talk about the alpacas in the Andes. What the heck? How did
yeah.
that cross your radar?
Yeah, I can give some kind of a summary of what people have tried. So we've tried
Right.
all of these things. So a lot of the sprays, they're salt-based or things that can break down proteins, right? So some of them use bleach, right? Hypochlorous acid or light bleach. And the idea is it will break down the allergens slowly over time when you spray the area. Now, the problem is you and I are made out of proteins. And so something that's degrading all proteins will hurt you. And
It,
that's the danger with some of these other things is they're not specific to the allergen, and therefore they're going to cause other issues. So the way I like to describe this is if you think about chemotherapy 50 years ago, it was terrible side effects, all these bad things that can happen to you, great drugs, but all of these bad things can happen because it's not specific to the cancer. Nowadays, we have these things called immunotherapy that's specific to the cancer itself. And so you have way less side effects. It's significantly more effective because you can use more of it. And so that's how we think about it. The cat food I love. Purina Live Clear. We're looking into them. They work okay, but the idea is really cool, which is the best way to neutralize a protein is to utilize these things in immune systems called antibodies. And
okay.
so 9 out of the top 10 drugs in the world are antibodies. And our immune system naturally creates them to deal with foreign things. So what they did, and because antibody production is extremely expensive, and so they were like, we can't produce these the natural way. Otherwise, it's going to be way too expensive. We can't make that into a cat food. So they injected the allergen. So they injected FeLD1, which is the cat allergen, into chickens. And it turns out when you inject things into chickens have immune responses, and then they pass that immune response to their children into the eggs. And so
Cut it out.
yeah,
Oh
it's crazy. It's a
God.
fantastic idea. And then they take the eggs. And so now this egg is loaded up with these antibodies and they'll make it in the food. And that's Pure Live Clear. It's
I'll be darned.
great products, great respect for what they've done there. The issue with it is you can think the chicken is having a lot of reactions all over the place, right? It's not just the thing you inject into it, it's reacting to other things in a barn, other things in the environment. And when you just inject something into a chicken like that, it's not the best of the best antibodies that it's producing. So when we produce a drug, we find the one thing that works really well, and then we create that one thing. And so we really wanted a way to create something that only targets the allergen and is really good at targeting that one thing and to produce it at a scale that made sense. And so antibodies are very expensive to produce. So we were looking at other things where it could make the economics work and it would be highly effective. And that's how we came across the alpacas. It's super weird. Alpacas and sharks have these interesting immune systems where they do have antibodies, but the antibodies are different in that portions of them can be produced using bacteria and very easily produced, and they can be highly effective. And so the reason antibodies are very expensive is you have to use hamster cells to make them, or other cells, or human cells, but mammal cells to make them. And as mammals, we need oxygen or other things injected in, so it's very expensive to make. We're tough things to grow. Whereas bacteria grow everywhere. I'm sure you've dealt with it, the nasty like pink stuff that sometimes shows up.
Right.
Bacteria are super hardy. They can grow anywhere, so it's cheaper to produce things with them. And we were looking into it. There's these two types of proteins, one from alpacas and one from sharks. And alpacas are slightly easier to access than sharks, but it turns out,
Even
yeah,
you got to go to the Andes, yeah?
yeah, it's actually there's tons of alpaca farms. So there, if you go to,
See, got it.
yeah, there's one in Connecticut we visit all the time with tons of hundreds of alpacas, and they just inject. It's the same idea as the chickens. They inject into the alpaca, but the difference is they don't rely on the alpaca to make it. The only difference, the key step here is they can then extract a little bit of blood from the alpaca, and they can sequence what is in the alpaca's blood that makes it neutralize the allergen. And so then we can put that into a bacteria and have the bacteria make it.
So are no alpacas harmed in the making of Pacagen?
They're, I am promised by the alpaca farms that they live the happiest lives you could ever imagine. So one alpaca can only been immunized twice. After it's immunized twice, they live a fairy tale dream life where they eat happily every day and they are happily on the farm forever.
And they give their fur.
Yeah, and they get their fur. And so
So,
then they're used for their fur. But so a lot of the alpaca farms in the United States now, that's how they make part of their money is these
yeah.
drug companies will try to make these things called nanobodies, which are the alpaca's immune system that helps neutralize things. So we work with them and we have great relationships and that's how we do it. So we don't manufacture anything using alpacas. We take a very small amount of their blood and then we sequence it. We figure out what's in it that makes it work. We select the best of the best thing in the alpaca's blood and then we put it into a bacteria and have the bacteria make a bunch of it.
Oh my goodness. Now, you said in when you first wrote to me that you've invested $2 million in this. Now, is this just from friends and family, and are you very rich? Or is this friends and family that each gave you $50 and you have a huge
I have a lot of friends, but I don't have that many friends. We have many great investors who put a lot of faith into us, and they invested in this idea, which is can
wow,
we use biotechnology to make better consumer products that help people? And
nice.
this is what drives us every day. Our team works super hard to sell these products. Our team works super hard to invent these products. We still spend around $2 million per year trying to invent new things. So
That must be such a trip for you
it's
as a couple.
amazing.
Meanwhile, your wife is employed working for a big pharma company that makes cancer drugs. But does she like, do you over dinner and breakfast, do you talk nanos?
Yeah, actually, the biotech industry is really interesting. There are trends of what types of solutions are hot, right? So things that investors want to invest in, things that the FDA will approve very easily. And
Can you
so, of
tell us what they are? What are these categories? Not that I'm so good at growing bacteria myself, but it's
course,
interesting for us to learn how the world goes round.
of course. So the most basic type of drug, if you go like 50 years ago, are these things called small molecules. So these
Okay.
are just normal chemical entities that do something to the body. The issue with them, and they're great, right? So they penetrate the skin very easily. They can also circulate the body really easily. The issue with it is because they're very small, they're sometimes not as specific as other modalities. So you can think small molecule, I'll give you an example, retinol, if you've heard of it for skincare, that's a
Yep.
small molecule.
Okay.
Vitamin C is a small molecule, right? So all these things are small. Minoxidil is a small molecule. Finasteride is a small molecule. All of these things are small molecules. And so 50 years ago, that was the gold standard. For the last, I want to say 30 years, there's been this new gold standard, antibodies, which is the natural human immune system to neutralize things. So if
Okay.
I know what's causing issues, right? So if I know what's causing the cancer, if I know what's making the cancer worse, I can then design an antibody or I can select for an antibody that will neutralize that thing. And up until around 10 years ago, antibodies were the main modality that everybody believed in. 9 out of top 10 drugs are antibodies. They were huge. Since then, there have been a lot of really amazing inventions. Nanobodies are one of them, which are from alpacas. SCFVs are the nanobody equivalent, except from sharks. You can engineer cells so you can take immune cells out of somebody's blood and then engineer them so they're like hypercharged and ready to kill cancer. So that's called cell therapy. You've probably heard of the vaccines. That's mRNA therapy. And
Right.
yeah, so that's been a big trend. It's really easy to engineer. And then the hottest thing, actually, which I personally think is really cool, they're called antibody drug conjugates or ADCs. And what these are is they're antibodies, except what they do is they have this payload attached to them, so a drug attached to them.
Oh.
And that drug generally kills things. And so the idea is I have this antibody that targets cancer. And so it will bind to the cancer, but it might not kill the cancer. I then attach something that it's like a bomb. It will kill everything around that area. So basically the antibody is a heat-seeking missile. It will find the cancer cells, and the drug itself will kill it.
So
So
it's like at one point in time, ancient times, and this may only be apocryphal, they would fit a dolphin or something with a bomb and it would know to go to a submarine. Was it like that? Very
exactly the same.
like that.
Yeah. So the bomb here is the drug, and the dolphin is the antibody. And
Wow.
for the last 5 years, that's been the hot modality because it's really smart, right? You sometimes antibodies aren't as good at killing things, and so you need to give it a little bit of a boost, and people have seen really great results with it.
All right, so Pacagen, where does it fit in that dolphin with a bomb
Of course.
modality? Because people who are allergic to cats,
Yeah.
their significant others or other family members,
Yeah.
it's a really big deal. People adore their cats, and there's people willing to stay on pretty unpleasant antihistamine drugs for their life which have side effects and at some point stop working.
Yeah.
So how does Pacagen fit into this landscape of newer technology?
Course. Nanobodies are pretty new. The first approved nanobody drug was FDA approved in 2019. So it's a relatively new technology. As you can probably tell, like people weren't messing with alpacas 50 years ago. It's most recently we've been like, oh, this alpaca is weird. Let's delve into it. Let's figure out what's different about it. And that's how they discovered nanobodies. And so what we do is the reason these allergens cause issues aren't actually because the allergens themselves are really harmful. They don't kill things in your body. If my hand is the allergen, you can think of the ring on one of my fingers as the part of that allergen that might cause an allergy. Right? So
Okay.
your body has these guard cells and these guards all over your body, lining your lungs, your throat, all these different places. And the instant it sees something that could potentially be dangerous, it overreacts. So
I see.
and that's what an allergy is. So an allergy is your body saying, "Get this out of me right now." So think about the stuffy nose, the
Yeah.
sneezing. That's you being like, "Oh, something is in my system. Get it out. Please get it out as soon as possible." And so what we do is we design the nanobodies are things that bind to other things really well, right? So that's what antibodies are. That's what these protein binders are. So the antibody just comes in and binds to that ring area. And so it just covers up the ring area. So when this complex enters your system, so you breathe it in, you don't see the ring anymore. And so you don't have that allergic reaction anymore. And
That's
so,
wild. It seemed you make it sound so simple. Were you the pitch man when you were going out for money? Because you're
yeah,
really good at describing it. Were you?
yeah.
You're still obviously a serious scientist, but you're able to describe it in lay terms, not dumb it down, but just make it more visually
Thank you.
acceptable to those
Thank
of
you. Yeah.
us that are, what? Huh? Alpaca?
I it
Nano?
really is that it's really that simple. So we're really just binding things. We're trying to make sure that allergen can't harm you anymore. And it's very specific, right? So one of the keys about this technology is it only targets that one allergen. It's like a lock and a key. It only opens that one thing. It doesn't mess with any other proteins in your system. These allergens, and we have ones for dogs now, and we have ones for dust allergens as well. And the thing is, these, except for the dust, the dog ones and the cat ones, those allergens aren't useful for the dogs or cats. And so they are generally pheromones or different things that they release to talk to other cats or talk to other dogs via a chemical or protein entity. But the cat doesn't need it at all, which is why Purina is selling something that binds to it in its mouth. If you're just targeting this one protein, it's completely safe for humans, it's completely safe for the cat, and everybody should have a good time.
That's interesting. And there's the dog one is a completely different allergen than the cat one, right?
Yep. So actually, there's two main allergens for dogs, and so we redid the project twice. So we had to inject two alpacas, and then we
And
asked
in
for a little
fact,
bit of the blood.
two little bits of blood, and from
Yeah.
that you were able to find the allergen, the what that you needed, not the allergen. What was it you
The,
could find?
they're called nanobodies, but
Oh,
they're fractions of the alpaca's immune system that are really good at binding to and neutralizing whatever you put into it.
so who, at what point in time did someone say, "Man, these alpacas, what, never got sick? Do they have the immune system of Superman or what?" How did anyone target them and not a goat or not
Yeah.
donkey or something?
So we have done a bunch of research on a bunch of different, not us, Pacagen, but like us as a scientific community. We've done a
That's
ton of work in this. I would say alpacas are probably the most tame. But if you think about the shark people, like somebody was like, I'm just going to take some shark blood and see what's in this.
a little hard.
But they did it. And this is where I will actually just a little side piece. This is why basic science is important because you never know what you're going to find. And
Mhm.
it's why it's really important that schools have money to be able to do these projects that
Yes.
sound like they're not going to lead anywhere because you might just find that a weird furry animal in the Andes has the secret to cure a bunch of cancers.
Yes, or things that haven't come down the pike yet, or maybe, who knows, genetically passed on
Yeah,
illnesses or diseases. Yeah, it's good to make that sidebar and say that research matters.
yeah. And
And
we
you
stand on
can't
the
cut
shoulders of
off
giants.
funding, you can't cut off funding to research because
Yeah,
you stop human exploration into the nature of illness or even the nature of wellness. What if you discover something about what keeps a certain race of people, a certain class of animal illness free?
yeah,
There must be some, it isn't like the 110-year-old person on a Greek island drink ouzo and
Yeah.
eat yogurt. That really isn't science. That's one lucky person or 17 lucky people.
Yeah. And that's actually how they discovered one of the hair loss drugs,
No way.
finasteride. Yeah, is there was this group of people that weren't getting prostate cancer and also weren't getting hair loss. And they were like, why is this happening? So then they dug in, they did a lot of genetic analysis, and they found this one mechanism that's really important. But
No kidding. See?
yeah, this
Yeah.
is very
I mean,
important.
those of us that don't understand the process that goes into the end result, I hope that all of us understand that research in and of itself is part of what for humans like you that have the capacity, the brain, the training, it's what you're here for. It's what yourselves is here for, exploration. Like in the 1800s, people would take a sled dogs and a
Yeah.
boat and they'd be Shackleton and they'd go off and they'd explore, I don't know, frozen tundra, but you have much different things to explore as a modern person.
Yeah, and it's really fun. I have to say, this company has been one of the most fulfilling to build because we help people with cats, and those are the best people. And I've now converted. My meow has completely converted me. She's the cutest British Shorthair, and it's just nice. It's nice to know that people can cuddle with their cats. People can spend more time with them because of our products.
But by the same token, what you're saying is what you've learned could also apply to some horrific injuries or illnesses down the road. What you've learned. When I say horrific illnesses, I don't know, like spinal cord injuries. I don't know. It seems like there's no limit to what you can learn once you start to look. You guys, not us.
Yeah, the scientists. Yeah,
Community. Yeah.
I sell cat sprays now, but other scientists all over. I have tons of friends that invest a bunch of effort into looking at all these different things, and you never know what you're gonna find.
Because the community does share. Until you
Yeah.
patent it, you don't really share, right? Because you
Well,
have to control what you've learned.
I think you'll find that most scientists, the people that are actually inventing these things, they just want people to use their
Yeah.
inventions. And
Yeah.
so there's a really open attitude towards sharing, even things that might be proprietary. People are trying to come up with the best solutions out there. And
That's
so it's a nice community. It really is a community that's trying to help.
it's not cutthroat. It's not like people trying to steal things out of your computer.
It can be cutthroat, but I think the thing to, just a caveat for science, right? There's no scientist does science to make money, right? If you want to make money, there are a bunch of other routes that you can do to make money. Scientists just going into a PhD program, you make very low amounts of money for 5 or 6 years of your life. And
Right.
you put your entire family life on hold. There's a bunch of things you put on hold because you love the subject that you're working on. And I think there's been some people upset at the scientific community for different things. And I actually think some things the scientific community did incorrectly. But for the great majority of people, especially the students, they are there to help people and they're there to really learn and try to figure out the potentially life-saving therapies.
And learn from mistakes. That's partly
That's
how
right.
you learn from your mistakes and other people's. Like you said, you're
Yeah.
standing on the shoulders of giants, some of whom slipped and fell.
Yeah.
Their slipping and falling taught you something or sent you in a different direction. So Pacagen is spelled Pacagen, and we can buy it any place one buys such pet-related things, and you
Uh,
spray it in your space. Is that how it works?
yeah. So you can spray it, for example, if you're allergic to cats and the cat goes on your bed, you can spray your bed. You can
Okay.
spray your couch. You can spray all these different areas. We also sell a food topper that you can put on top of your cat's food.
Ooh,
And
I
so
like that idea. So you get it from various directions.
that's right. And in that way, it neutralizes what's in the cat's mouth. It's mostly chicken broth powder, and then we add our secret ingredient into it that neutralizes the allergens.
The secret sauce, the secret Pacagen sauce. So that's it. If you're allergic to dogs or cats, you can get the specific Pacagen spray or food topper, and then you're not allergic anymore. And now you guys have to work on more cool things, which I'm sure you're already doing.
Yeah, it's a lot of fun. We really like working in this space. It's a lot of fun helping people and trying to figure out, different ways to help people.
That's great. I hope that you and your wife and Meow welcome some other either four-legged or two-legged people into your life. And in the meantime, work well and work hard. Evan Zhao, it's really nice to meet you. And the story of how you got here is a great lesson for all of us who don't understand biology very well, but we're proud of you. And thank you on behalf of all the cat lovers who no longer have to sniffle.
Thank you so much, Tracy.